Welcome everyone to the 2025 SONiC Mentorship Showcase event. Today is February 10th, and really happy to be here and have everyone participate, from last year's mentorship. And we're going to get started by going through the agenda, and yeah, really looking forward to this event. Okay, so our agenda, it's pretty simple, straightforward. I'll be giving a program interview or overview, sorry. And then we will be jumping into the presentations by the mentees. So I just want to thank everyone for being a part of the showcase. It's a really exciting event, and I'm happy to see that everyone's here. Um, Before we jump in, I just want to introduce everyone to our former SONiC mentees. We have Aditi, Reddy, uh, Kalyan, Pullela, and Gaurav, Nagesh. Um, they will be giving their presentations as well as a Q&A. And yeah, I'm excited to hear from them and just see the work that they did. I know that some of their mentors are here as well, so that would just be really exciting as well. We started the SONiC Mentorship Program last year because the SONiC community wanted to have college students introduced into the SONiC ecosystem. We believe that mentorship is a beautiful opportunity to integrate college-age students into cutting-edge open source initiatives. The SONiC community is constantly growing, and we have a lot of amazing work that is going on across the 22 SONiC working groups. As we look forward to the upcoming 2026 SONiC Mentorship Program, again, I just want to thank everyone for participating and being a part of this event. Before we jump into the recordings, I'm going to allow Tracy Lee to just give a few words about mentorship.
Thanks, Evan. So as Evan said, I'm Tracy Lee. I'm part of the program management team here at the Linux Foundation. Evan and I are fortunate enough to work together on SONiC. This is a wonderful foundation filled with lots of technical expertise and talent. And we were very excited last year when the TSC tasked us with exploring opportunities for SONiC to introduce its first mentorship program. So this program, when we kicked it off, some of you may or may not know, the mentorship program itself is actually offered through the LF across multiple projects and foundations. SONiC was very easily able to kind of plug into that program and experience it for the first time. As Evan said, we had a lot of interest from the SONiC community in terms of the mentors, as well as from the students themselves. And we were very excited with the level of interest. We had more applicants than we could possibly place, and we had some great projects. This is a really nice opportunity for the SONiC community to bring in extra technical expertise to, an extra resources, if you will, to these particular projects that are important to them. And it's a great opportunity for college students to learn a little bit about SONiC. The program was so well received, in fact, that we actually are going to be expanding it for next year and offering positions not only in the US, but also in India and China. So more to come on that as we start to plan for next year. But for right now, we're really excited to take this opportunity to hear from the mentees and some of the mentors who participated in this past year's program. Evan?
Yeah, thanks, Tracy. That was really great. Well, with that, let's jump into the presentations. So these are all pre-recorded. So all I'm doing is just pressing play, and then once the presentation is over, we will have a 2 to 3 minute Q&A session with the mentee. All right.
Hello, everyone. My name is Kalyan Pullela, and I'm a graduate at Oklahoma State University. I'm also a SONiC mentee for the basic Azure pipeline with Alpine and K&E project. Here were the expected outcomes for this program, but I was not able to complete all of them. I got to the third part with some caveats. I was able to bring up and set up an Azure pipeline for a small VM on a personal GitHub, but was not able to bring up K&E and Alpine in the VM due to a couple issues that I will address later on. The extent of what I was able to do is execute tests on Alpine in my local VM. But first, let's answer the question, what is Alpine? It is a recently open source SONiC virtual switch developed by Google that leverages the development to accelerate software delivery. It seamlessly integrates with various vendor simulations like PCMSim, as shown in OCP 2025 video. Alpine also enables highly scalable fabric level testing with the help of its fully open source lightweight data plane called Lucius. Another added benefit is that it is deployable on public cloud over the Kubernetes cluster. Now that I've discussed Alpine, let's jump into my experience during this program. I initially started by setting up a mock pipeline on a personal GitHub repo to learn about how to actually use Azure pipelines. It had a small VM that I could provision using my student account, but that VM was not enough for the requirements of building Alpine. The reason being, when we first started, it was not fully open sourced, and I ran into a lot of issues while building the project. The chief problem was that I needed a VM that had over 80 GB of storage and 24 plus cores, which my laptop definitely did not have. But we could not diagnose this immediately, so we had to spend some time to arrive at this conclusion and provision a VM that actually had these requirements. With the help of our mentors and their team, I was able to progress and arrive at the next set of problems. The first was the crashing of containers, which required some targeted debugging. And similarly, I had to also update the test bed file to ensure that my spy test would actually create, because this test bed file was what would help me actually execute the test, which we will see in the next slide. And so now after arriving at the stable build, I began testing Alpine by executing the SONiC management security test. The first thing we needed for this test was to set up a SKP traffic generator. The issue here was that I did not know how to ping between multiple devices on Alpine. So Brian, Arpita, who are my mentors, along with Aditi, who is my co-mentee, and I sat through an intensive debug session where we dug through endless PCAP files to identify the problem and found out that to fix this, it was as simple as just assigning the other device's IP address so that your device can connect to it. The next issue that we had to deal with was that a bunch of Ethernet ports were showing admin up, but operationally down. This led to a rich discussion about QSFP, OSFP, and how links get aggregated in switches, not just virtual ones, but also real physical ones. To fix this, I basically had to dig up all the links. I had to bring up all the links by updating my topology file in order to enable this part of the test to continue. Skipping ahead a little, another problem was the router interface type VLAN was not being implemented, which required a deep dive into the routing file to then code it up. Moving on to the actual biggest issue that I had to deal with was the IP to me issue. And for some background on the L3 sanity test, one of the tests that it runs is that it creates a route entry and then deletes it. But the issue here was that the route is automatically being stored in the FIB table, but during remove, it's being looked for in the IPv4/IPv6 trap table. This mismatch led to Arcadian and Swiss completely crashing out. To fix this, I had to add tracking for these specific routes so that when they're being removed, it will remove from the right table and execute as expected. Finally, the mangle prefix problem, which was an issue that complemented the previous problem. The trim prefix was being used to help with storage and search, but was not working properly at all. So I had to make a quick change to ensure that it would not affect the original input and it could be used during search. And for future work, though we discussed a couple issues in the previous slide, I have not been able to fully execute this test file. That will be my main goal going forward, followed by which would be to enable them as part of the actual SONiC pre-submit pipeline and bring up the Azure data pipelines. Finally, I would like to integrate Alpine with other open source platforms that could really enhance its ecosystem. I was able to do this in the SONiC hackathon last year, but I would hope to build on that. Finally, I would like to thank my mentors, Brian and Arpita, who took a lot of time out of their busy schedules to help with my random questions. And I would also like to thank Sonika and Sri, who are valuable resources and supported me throughout this program. Thank you.
Awesome. Thanks, Kalyan. All right. Um, Q&A. Do we have any questions or any questions about the presentation or Kalyan's mentorship program from last year?
I just want to say thank you to Kalyan. It was a pleasure having you. And I really thought you did a great job working in the face of adversity and kind of in an unknown environment or a rapidly evolving environment to solve these problems. So
Thank you. I mean, there's a
great,
lot of
great work.
things walking in I didn't know. So it was great. It was a great discussion. I learned a lot, honestly, more than just actual Sonic based, just in general and networking. It was a lot of fun. Thank you. And to Arpita as well. I think she's also in here. Uh,
Kalyan, I'm wondering, are you using this for anything in your degree now?
so yeah, actually, we're not Alpine directly, but through this, I'm actually trying to get into Dash to get into more of the SmartNICs. But yeah, we are. I have been exploring over the last 2 weeks Sonic Dash specifically. So yeah, but not Alpine directly.
Well, cool. That
Thank
sounds
you.
like those are all the questions that we have, our Q&A. Um, our next presenter, it doesn't look like she's here right now. I know she said she'd join, but let's just jump to our third presenter, Gaurav, and we'll get started with his presentation, and hopefully by then, our second presenter is here and we can just circle back.
Hello everyone, I'm Gaurav Nagesh, a graduate student from Illinois Tech. I'll be talking about the project I worked on titled Enhancing Redis Access Efficiency in SONiC. This will be the outline of my talk that I'll follow. So coming to the background and motivation, the main motivation behind this project is that Redis is a centralized database in SONiC and almost all the components interact with it in some way or another, making it a very critical component in the entire SONiC subsystem. And because of this, it becomes a key area of performance improvement. Now, when we say Redis performance optimization, it can be divided into three areas within SONiC. First is improving how application code interacts with Redis, or it can be enhancing the Redis SONiC client library. That could be things like the actual command and query formation, etc. Or it can be tuning the Redis server parameters for our workload, which can be server configuration parameters like memory allocation library or TCP backlog size, etc. So our focus of this project is the first one, particularly focusing on the platform daemons. Some of the key goals of the project are profiling and benchmarking each daemon to establish a Redis performance baseline, and then use that to analyze the current Redis access patterns, whether it is write heavy or read heavy, and identifying any redundant operations to reduce the unnecessary Redis traffic, and overall to increase the robustness of Redis operations within the daemon. Now, the first step is to understand how each daemon interacts with Redis, and this can be done in two ways. First is using profiling tools like PySpy to generate flame graphs, which will help us identify the hot paths, especially around the Redis database calls. Second is tracing every Redis operation end to end to capture its execution behavior, which is done using a custom tool that I wrote. So this is the environment setup used for both the baseline and optimized versions so that the results are reproducible. And these are the various benchmarking tools used PS record for CPU and memory consumption, PySpy for flame graphs, Redis CLI tools for table schema and other server statistics, and a custom Redis tracing tool that I wrote called this was Common Profiler. And it's basically a Python module which helps us to intercept and trace every database call made by the daemon, including in its subprocess and threads. So it works on the concept of like monkey patching and decorators in Python. Later on, I have an example log showing exactly how and what it's captured. And coming to like the metrics, some of the main metrics that we capture is the throughput measured as request per second. It could be a read or a write request. The latency measured in millisecond or nanosecond. Next is the memory or CPU usage before and after optimization. So this is to ensure that our changes doesn't deviate from its normal behavior and is well within the bounds. And next is the flame graph. And for more granularity of the Redis database call, we capture the following from my custom tool. So on every Redis call, it captures what is the Redis table being accessed, what is the command or query being executed, what is the latency of that particular operation, and what is the data being written or read, which is the payload, and what is the payload size. So now after analyzing the data captured, the implemented optimizations can kind of be classified into these three categories. The first is conditional writes with change detection. So the daemons, from what we analyzed, were updating all the attributes every cycle, even when nothing changed. So rather, we can only update during the startup and when things change. So including scenarios where platform components are hot swapped. And the impact this has, it has significantly reduces the unnecessary Redis traffic in the system. The second is better Redis connection management. So most of the daemons have multiple connections, even though they were single process and all operations are done sequentially to different tables. And third is batching Redis operations using a Redis pipeline. So instead of making individual set calls for each attribute, we can batch all of them and send it to as a single network call. So the impact of both of these is that it increases the throughput, reduces I/O and network overhead. So to kind of justify these changes, I have a couple of examples in the next slide. So this is to justify the Redis connection management. Here on the top left is the actual Redis pipeline class definition in SONiC. It takes a pointer to a database connector and its default batch size is 128, which creates an in-memory buffer. We can see here that it in turn creates a new database connector for the pipeline. And on the top right, we have two table constructors we can use to initialize and write database operations to that table. The important thing is in the first one, it internally creates a new Redis pipeline with a batch size of 1 and delegates the real initialization to the second one. So from the application or daemon perspective, whenever we perform any operation, example a set, it immediately does a push and a pop from the buffer and executes it as shown in the track trace below in the bottom left. So there's an immediate write and a read. And the code here in the bottom right is how normally all daemons initialize the database tables. The current table creation logic in the PMON platform daemons are defined as shown, where we initialize a database connection to StateDB, and then three tables are initialized by passing the same database connection object. And this has its respective along with its respective table names. However, as illustrated above, each of these tables will in turn create a separate database connection internally for the Redis pipeline with a batch size of 1. So making the total number of connections used by this code to 4. So this causes unnecessary load on Redis server because it has to keep track all of this. And since the connection is usually kept open infinitely, there will be a TCP keep alive messages and heartbeats in the background, all of which will cause unnecessary load. So what we can do instead is we can use just one database connection to send all operations requests and batch those requests, as well as using a single Redis pipeline to improve the performance as shown in the below code. So we can kind of further enhance it by declaring the first database connection as a local variable rather than an instance variable, so that after the constructor, it's garbage collected and we can reuse only the same pipeline connection for all the operations. So this is an example to justify why we need Redis pipeline. So here you can see both of them send 100,000 requests each with a payload size of 1,000 bytes, and sends the hash set command, which is the actual Redis command sent when we call the set function. We can see that the time taken and its throughput is almost 4 times better than without pipeline. And this is why we need to use Redis pipeline. Next is to justify why we need conditional writes to Redis. This is an example log from my custom tool. It captures the process ID, the thread ID, the table being accessed, what operations are being performed, how long it took, and what arguments was being sent or received. So I have a flag to kind of enable or disable the full argument list. And for this example, I've disabled it so that the output isn't too long. So this is an example from PCID where we can see that every 60 seconds, it writes the same values even though no values have changed. And this is why we need change detection and conditional writes. So this is the benchmarking results comparing the baseline versus the optimized version after implementing the changes. First is the average latency in millisecond. Lower is better, and we can see that the optimized versions all have lower average latency than the baseline. Second is the total duration in millisecond, which is the total time taken to complete one monitoring cycle. Lower the value is again better, and again all of the optimized versions have lower values. Third is the throughput. Higher the value is better, and we can see that all the daemons have higher throughput than the baseline. So overall, we can see some have 2 to 4 times better performance than the baseline. So the actual values may vary slightly in practice due to the dynamic nature of the daemons and external factors like the current system load on the Redis. So a certain variance is expected in these results, and accounting for some variance, the graph shows the range of performance improvement we get from all these daemons, with PCID being roughly 2 to 4 times, thermal control being 3 to 4 times, and PSU being 1.5 to 4 times than its baseline. So for the conclusion and future work, first, based on the lessons learned from this, we can extend it to other daemons in SONiC. Second is, as mentioned before, here we focused on just optimization from the application or daemon perspective. In the future, we can focus on optimizations from SONiC Redis database library and the Redis server tuning perspective. Finally, I would like to thank my mentor Vasundhara Vallam, who took out time from her busy schedule to guide me throughout this project. And also, I would like to thank Rita, who made this opportunity possible within her team, and Julie Joseph for giving valuable feedback and quick review cycles to get my changes merged. And thanks to the Linux Foundation team, Ivan, Tracy, and Sunny for running this program smoothly.
Thanks, Gaurav. That was really great and super in depth. Now, just taking the time to open this up to Q&A. Do we have any questions for Gaurav or any comments about his presentation?
This is Ryan. And nice talk, Gaurav. Which release did your changes make it to? It sounds like it actually merged to upstream. And is it enabled by default?
Sorry, I didn't get your question. Can you please repeat?
Hey Ryan, I would like to take that question up. So Gaurav has raised multiple PRs. We have merged a few exception handling and some of the improvements to 2511 release, and the other PRs are in further testing on physical test beds. So after, getting the benchmarking results, then we will be able to merge it.
Thank you. Thank you.
Great. Any other comments or questions for Gaurav?
I would like to tell a few words about Gaurav. Gaurav has kickstarted very enthusiastically and he ramped up very fast and he came up with very detailed documentation about Redis and understood how it works before jumping into the project. And he made good tools to compare between the existing and the improved versions. I would like to thank Gaurav for all his hard work into this and finishing the project as expected. Thank you.
Thank you so much for the support you have given me throughout the project and for the kind
You're
words.
welcome.
Thanks.
Awesome. Any other questions or comments? Okay, so I know we skipped over Aditi. We are going back because she is here, so I will start the presentation.
Hello everyone, my name is Aditi Reddy and I'm a graduate student at NC State. Before I start, I'd like to thank my mentors Brian and Arpita for their constant guidance throughout this mentorship, and also Sonika and Shri for all the technical discussions and support. I really appreciate the time they took to help me think through the problems and unblock so many issues along the way. The main objectives of this project were to understand SONiC Alpine's architecture, deploy it in a Kubernetes-based environment, and explore a path towards supporting a VPP-based data plane within Alpine. So what I'll be sharing today is not the entire project, but it's the progress so far, the key challenges I faced, and how each of them shaped the architecture I'm currently working towards. So at this point, I have two pods running in KNE, SONiC Alpine and SONiC VPP, and they're able to communicate and ping each other successfully. So moving on to the architecture of SONiC Alpine, it follows a two-container model. One container runs the SONiC control plane components like FIR, Swiss, and SyncT with state managed through Redis databases. And the data plane logic runs in a second container called Lucius. And the two containers communicate over gRPC. So this boundary is important because it allows data plane changes without modifying the SONiC control plane. So the first major problem I ran into was infrastructure. As we all know, SONiC builds are heavy and Alpine requires significant disk space and memory. Initially, I didn't have a VM with enough resources, so I had to move to a setup with roughly 80 to 90 GB of storage and high RAM before builds could even complete. Once the environment was stable, the next challenge was building Sonic Alpine itself. Alpine isn't fully open source yet, so getting to a successful build itself took time. I had to understand repository access, how Alpine integrates with Sonic build image, and what a correct build output looks like. These are the commands I'd use to get it to run. After this, I moved on to deploying Sonic VPP as a pod in KNE, which exposed the next major blocker. KNE requires devices to run as Docker containers, not VMs. However, Sonic VPP did not support standalone Docker image builds. The build system only produced full Sonic images. This completely blocked the deployment of Sonic VPP in KNE. So to fix this, I added proper Docker build support by introducing .deb files for dependencies, .mk files for syncd build rules, and Docker configuration files for image creation. This work became PR number 201, which now enables standalone Sonic VPP Docker images and makes Kubernetes native testing possible. So these are the changes I had to make to the topology file in order to have Sonic VPP running as a container. So once that was done, my next biggest challenge was interface mapping, which turned out to be one of the most critical parts of the project. On the VPP side, Sonic Ethernet interfaces map to Linux TAP interfaces, which are then paired with VPP DPDK interfaces using the Linux control plane plugin. So the libsci VPP layer translates SCI calls into VPP binary APIs that program the VPP forwarding graph. Getting this plumbing right was essential. Containers could be running, but if the interfaces aren't created and paired correctly, the packets just won't flow. So after validating interface mappings and VPP state, I ran layer 3 tests and successful bidirectional pings confirmed that traffic was flowing through the intended data plane path. All of this helped clarify the target architecture. So right now, Lucius provides a simple data plane for validation and experimentation. The next step is to integrate VPP into Lucius. So SCI calls flow from the Sonic container over gRPC and into libsci VPP through the VPP binary API and finally into the VPP data plane without changing the Sonic control plane. So this integration could be approached by integrating libsci VPP, adding the VPP process, and configuring the interface mapping. So to wrap up, while this architecture isn't fully deployed yet, this mentorship helped me build a stable Sonic Alpine environment, run it in KNE, validate data plane behavior, and define a clear path forward. The next steps include completing the VPP integration, benchmarking performance, and scaling to more complex topologies. These are the references used. Thank you for your time. I'm happy to take any questions.
Perfect. Thank you, Aditi, for that presentation. Do we have any questions or comments opening for
Hey,
her?
Reddy, even this Prince from Microsoft. I have a quick question. Is this documented in the Sonic VPP folder, or you're still working on that? Because this seems to be interesting, and if you
Uh,
have to do the same thing, we can refer those steps or guidelines, right? So,
yeah, hi, Prince. So when you say is this documented, what are you
like
referring to
the
specifically?
integration efforts and whatever you had to do, is it like documented that
Right. So
somebody else can? Yeah.
it's documented, but I haven't uploaded it anywhere yet.
Oh, okay, okay. Because I,
Yeah.
I remember like Sonic VPP people build it as a full image, right? So this would be
Right.
like,
So they had an
uh,
issue with the Docker image build, so that wasn't
uh-huh,
working. So I've raised the PR, and that has been committed. So
okay,
that's the work that's done. But the integration part hasn't been uploaded anywhere yet.
okay.
Yeah.
Yeah, thanks for that
So
question, Prince. Um, any other comments or questions?
I just want to say thanks to Aditi for all the hard work this summer and fall as well. It's really impressive, to take kind of this environment, even in just getting it working. So really, yeah, it was fun to watch you kind of explore VPP and kind of pivot a few times, and finally get to a topology that showed the two can interoperate.
thank you, Brian. Honestly, couldn't have done it with your support and Arpita's support. Thank you so much.
Cool. Any other questions or comments for Adit? Okay, that sounds like that's everything. Oh,
Aditi, how did you find out about this program?
Sorry?
How did you find out about the Sonic Mentorship?
So I was searching on I keep checking the LFX page for any opportunities or any work that's going on that seems interesting. And I'd also heard from a friend who had done the mentorship. So I knew there were opening slots, so I applied.
nice.
I think Aditi was a two-time SONiC mentee, right? The first summer was SONiC PvP, and second one was looking at PvP and Alpine together.
Oh, so the first one wasn't an official LFX mentorship or anything as such. That was just kind of from my own interest and from people that I knew.
Okay, cool. Well, that sounds like those are all the comments and questions for Adit. Um, well, that's all that I kind of have today, everybody, for presentations. Um, let me see if is Liwa. Okay, not on the call. That's all right. Okay, so thanks everybody for joining and participating, and for all the mentors and mentees, all the work that went into last year's program. Um, I know it was a lot, and um, just kind of roughing it because this was, Sonic's first time starting it in a while. So thanks for your patience with from the PMO side and just with everything. It sounds like and looks like you guys did some really amazing work, and there were some questions from the community and some benefits to the work. And I know as a Sonic community, we're really looking forward to, hopefully this is just the start of your interest in Sonic, and that you can continue to be interested and contribute. Um, the 2026 mentorship program is still underway, where we are getting those proposals out, and those will be live shortly. So, if you are interested, or you have any friends or that are interested, or people or other people that might be interested, please share when those are posted. They should be posted. I think the beginning of March. That's when they'll be live. But other than that, thanks everyone for joining, and enjoy the rest of your day. Thank you so much.
Thank
Yeah,
you.
thank you, Evan. Thank you for so much
Yeah.
for all the initiatives and efforts. Yeah.
Yeah, of course, of course. Bye.